Hello everyone, and welcome back to a new episode of Silicon Zeros. We're still in the tutorial, but we've gotten through more than half the tutorial puzzles, but I suspect that these are more actual puzzles, whereas these were just instruction manuals. I don't have any strong feelings about which one to start with. I'm going to leave this question mark one alone for the moment, I guess. Let's just start from the left and do sort of a breadth first search, I guess? Or breadth first traversal? Sure, why not? We'll start on stall. Who's giving us this one? Carol. Hardware engineer. I've been thinking about very simple devices. How few parts could you take to build something that sets memory slots 0 and 1 to both 1? This might be a dead end, but it seems like it could be a fun little idea. I think we've got time to play around with it. How few parts set memory slots 0 and 1 to 1? Okay, and there's nothing in memory now. And it only has to be that way temporarily, right? So let's see. We could obviously use 2 number inputs and 2 writers, right? That's one thing we could do. Just have access to as many 0s and 1s as we want. Is there some way to be more clever? What is this thing flashing down here? Oh, initial memory. Oh, and the goal memory. That's cute. Okay, so that's how I know, in case I forgot, how I know what I'm aiming for. Okay, well, let's do the obvious thing first, I guess. Let's just take a 0 and a 1, and 2 writers. Let's see, writer is on 2W? No, 2E. I'm trying to do that. I was trying to do that without looking, because I want to be able to get to the... Oh, that's a reader. Go away. Oh, I see. They're not giving me... No, that's a latch. Okay, so I don't get another writer or reader. Alright, so the obvious way isn't going to work. That's cool. I was thinking of... Sets them both to 1. So, alright, we want to wire this 1 up to here. And, honestly, I think... How do I... Go away. No, not like that. This. Delete. Alright. So... This starts outputting a 0, so we can set that there, right? It'll write to memory slot 0, and then in the next time cycle, we'll feed it a 1 to send in for the next cycle, right? Like, this must be the answer. So we simulate 1 cycle, and we're writing a 0 to slot, or 1 to slot 0, and now the latch is set to write a 1. Oh, that's cool. When you mouse over it, it shows you. Cool. All right, I wasn't sure why things turned blue earlier. So we do again. Now we put a 1 there as well. Alright, cool. Great. So puzzle select. We're done with stall. How about counter? This device, I think, will be a cornerstone of what we do at ZeroCom. It should set memory slot 0 to 0, 1 to 1, and so on. Alright, this sounds like a job for like a latch and an adder. Alicia has set up the memory to display the correct output. Just select view memory goal in the bottom right to see it. Oh, they should have told me that before this puzzle. Or before the last puzzle. Once this is done, I think we'll finally be able to... ready to explain the purpose. This is the last piece we need. Alright. So what pieces do we actually have available? We have numbers and adders, and we have a latch. That sounds about right. So we're going to do something similar to what they did in the first puzzle where they introduced latches. We're just going to take a number... Actually, do we need a number? Yeah, we need to add 1, right? And we need a latch, which which is wired up to both the slot and the thing. Let's see, and then we need an adder here where we take this thing's output. Ugh. I know it doesn't matter where I put anything, but... So we're gonna do something like this, where... Whoops. 0 to 0. So this would work, except it would be off by 1, right? This is, well, let's test this and see what it does. So we stored, wait, it worked. Why? Go back. I thought this was gonna not work. Ah, I saw the 1 here and thought, oh no, this is wrong. We're putting a 1 here too soon. But we're not. Remember, it doesn't, its output, the latch's output in the first time step doesn't matter, it doesn't depend on what's here in the input in that step, because the input just affects what it'll output in the next step. So this is perfect. We start by outputting a 0 to slot 0, and we put a 0 here. Then, in that same step that we wrote the 0, we compute a new value, 1, and put it here, and then we're sending a 1 for the next phase, and then a 2, and so on. So, indeed, it's doing exactly as we want. How do I say go? Just, here we go. Great. Now that you have built this Dana, I am convinced. You are the one who will build my dream. Boy, I want a raise. Zerocom was founded to create a computer, not a room-sized monster, one small enough for the home, cheap enough for every family to own. Our mini-computer could change the world. Put all human knowledge at every man's fingertips. Level society, abolish inequality, render work a luxury. Is that not worth working for? Okay, so this is set in the past, I guess? Maybe I should have figured that when there was someone who looked sort of youngish saying she was married in the 60s. But, okay. So we could carry on to these, but I said I wanted to do breadth first, so I'll do rewrite and spares before I move on to these two. One last piece of work for the external memory. We need to test its durability. Really hammer it with repeated writes to the same memory slot. Without configuring modules, get memory slot number 1 all the way up to 8. 8 writes should be enough to prove the memory works or that it doesn't. Fine. So this is going to be a similar thing where we'll write to a thing, and then read that same value and add 1 to it, probably, right? So we've got an adder here already. What do I have? I have access to numbers, but I can't configure them. They're stuck at 1, which is fine. That's all I wanted. And I have a reader and a writer. I'll need both of those. Okay, so the output of the adder is what we're going to write. And how convenient that it's slot 1 we want, because that's the only number we can get. Something like this. So we're, I just sort of like wired things up to where the only logical place they could be is. I haven't worked out whether this should actually work. So every time we go to write, we'll write to slot 1 a value, and then we will also, well, first, I guess actually this happens at the end of the stage, right? This all happens like before time begins, basically. We read from slot 1, and that instantaneously returns 0, because that's what's there in the initial memory. And we add a 1 to it and write a 1. Ta-da, that's step 1. Step 2, we'll do the same thing, except what we read will have been 1 instead of 0, and so we'll write some bigger numbers. Okay, great, so that should be all, right? Yeah, got a little counter here. Nothing melted down. This is probably the last I'll be working with you on memory. New equipment's come in, so I'm finally switching over to programming. You know, there's not a lot of places I get respect. They say programming, that's unskilled, women's work. Zerocom's different. Laszlo's made a place where I can work and feel like a human being. So whatever he's planning, I'll pay him and you back with the best programming I've got in me. Well, thanks, Alicia. Okay, and then, oh, spares, that's right. So, spares. Carol's giving me some good news and bad news. So the good news is she has a subtractor. bad news is that she's having trouble keeping up with your use of adder and number modules. I wonder if you can substitute those parts away. Do you think you can build a machine that doubles the value in memory slot 0 without them? Okay. So there's a 43 and we want an 86. There's multiple tests here. Have there been multiple tests on all the others? I guess we'll... Probably that last one about validation or verification or whatever is going to teach us about the multiple tests that are being run. Okay. So... What do we have? We have a subtractor, read, write, and latch. A subtractor. And we need an adder. We can't have any numbers, but a latch gives us 0, sort of, once. So let's try something like this. We'll take a latch, which is initialized to 0, and we'll give it a subtractor where we want to subtract from 0 the value, so that's a reader, in slot 0, and we need a 0, so there we go. Subtract from 0. Now we have a minus 43. And if we can subtract that from 0 twice, we'll get up to 86, right? So we'll need a few more subtractors. Probably 2 more, right? So there we go. We're back up to 43. And just use one more. Wait, hang on. Not a 0, but this. Ta-da! And now we just need a writer to slot 0 that takes this. So I don't know how clear I was in vocalizing what the plan is here, but the idea is to, in order to increase our number, we need to subtract a negative number. And the only way to get a negative number is to subtract what's in this memory value from 0. That gets us a negative number, and we subtract that negative number from 0 to get us back to where we started. Wait. I just made myself 2 copies of 43, right? I don't need this module at all. I can just take this one, put it there. Right. Go back. No! The wires cross and I can't make them stop. Oh well. Yeah, this is more reasonable. We'll read this value twice. We could reconstruct it with another subtractor, but this is cleaner. So we read 43 twice, once to get a minus 43, and another time to add that, to subtract that minus 43 from the original 43, doubling the input. So that should... Oh! I hit test and it like blinked. I guess... I don't remember it fading out and back, but okay, whatever. We did it! Sorry for butting in, but Laszlo told me what you were doing and I just had to take a look. Quite a thing you've cobbled together, huh? I'm a fan. The weirder the design, the better, as long as it works. Yeah, so there's nothing better we could have done here, right? I don't think so. Of course, we'll write it with something... If we run to tick 2, something different will be written, but that's not the goal. Okay, fine. So back... And now we have validation, where they teach us about these multiple tests, I suppose. Yo, I've been working on a validation system, and I want you to break it. Look right. Yeah, we've done that. You'll see the test at the top of memory. You can use the arrows there to switch which test you're looking at. In each test, you can mouse over values to view the goal. Enter the sim, and you'll see a validation screen flash by. That's us running tests. We run every test every time, and show you the first one your machine doesn't succeed at. It sounds like the Malevolence engine from Manufactoria. Build a machine that passes the first 2 tests, but not the third. Alright. Ah, that's what this was all about. Validating. Okay. test 1. Can I look at... How come I can only see one of them? Earlier I could see... There it is. So we want... This is our initial memory and goal memory. So we want to add 1 to... We want to get... The output from 1 should be 2. The output of 2 should be 4. And the output of 3 should be 12. Okay. We want to fail the third test. So we just need to double the input, right? That'll pass the first 2 tests. 1 will be 2, 2 will be 4, and 3 won't be 12, so we'll pass. Alright, give me then a reader and a number. We need slot 1. And I guess I need an adder. We'll just add this number to itself, and we will write that value back out to memory, right? Enter the sim, yeah, okay. Test 3 fails, yes. What am I supposed to do about it? Build a machine that beats the first 2 tests, but not the third. I did. Didn't I? Am I supposed to watch it fail now? I guess so. Hey, I know I might have made a bad impression earlier. I already said sorry to Carol for all the messing around, but I thought I should say something to you. To me, most work is pretty easy. It sounds nice, but it gets boring fast. Sometimes boring enough that I start causing trouble. Sorry. That's why I'm here, though. If there's anywhere I can find a real challenge, it's at ZeroCom. Trying to keep up with you and the others. Fine. Great. Apology accepted, although I don't remember your name. Increment. Here's the first application of your counter, a device that goes through memory starting at slot 0 and sets each slot to its original value plus 1. This design has industrial applications. It should be enough to provide some revenue, which, sadly, we need, I don't know if that's sad, if ZeroCom is to fulfill its purpose. This will be the most complex machine you've made yet, but I chose you for this group for a reason, Dana. I am excited to see what you make. Sets each slot to its original value plus 1, starting at slot 0. Okay, so we need a counter for the memory address, which we can do with a latch. We have access to everything we've ever known about except subtractors. Okay. Well, tell you what, let's get started by just building the counter. So I'll need a number, that's our 1. And a latch. And I guess we need... We've built this before, but it's good practice. So this thing is going to send its output to... Oops. To this, write it back here. So this is our counter, right? Let's test this. Step. Yes, indeed, it is outputting larger and larger numbers. Very good. Fine, I'm done testing. Go back to the edit menu. Now what do I need? I need a reader that reads from the address indicated. An adder, which takes this value and adds 1 to it. And finally, a writer, which writes to the original address the value output by the adder. Right? Seems legit. The wiring is a bit messy. Alright, well, I could try to step through all this in my head and see how it works, but that's what this testing engine is here for, right? Tell me what I have messed up. Okay. Test 1. Well, that's a little bit worrying. Oh, this looks like it's working, right? Do I have to play? Lighting the spark. We got an achievement, guys. I don't think you can see it, but we got an achievement for finishing the tutorial. If ZeroCom is to advance mankind, we must act as a business. Otherwise, we will go bust. But I do not have much of a head for money. Good thing I know how to add things. I have been talking to a businessman named Jack. He agreed to join us if we had a real product like this incrementer. I think you will meet him very soon, Dana. I am very excited for where we can go from here. So if I go to puzzle select, am I no longer in the tutorial? Whoa! Okay, there's like the table is lit up. And there's board 2, the CPU. Alright. Well, I think that this has been a fun tutorial, and look down. Okay, sure. The glowing light from heaven was enough of a tip-off, but this is cute. Anyway, this has been a fun tutorial, and I don't really have time to record anymore today, but I'm looking forward to seeing some real puzzles and seeing what kind of complicated stuff we can build with these simple pieces. Hope you guys have enjoyed. Thanks for watching, and I'll see you next time.